Hey everyone, and welcome. Today, we're jumping right into a brand new explainer, and we are looking at something completely fascinating. We're going to explore the high-stakes, honestly, kind of mind-blowing parallels between delivering a perfect marketing message and securely updating a car's firmware over the air. The anatomy of flawless delivery. Let's get into it. So, ask yourself this. What on earth does writing a 30-second TV commercial have in common with beaming a massive multi-gigabit software update to a modern vehicle, like a Genesis? I know, it sounds totally crazy, but both of these processes rely entirely on extreme compression and high-stakes, absolutely flawless execution. Think about it. If a TV ad misses the mark, the viewer just changes the channel, right? And poof, millions of dollars in media budget just vanish into thin air. But if an over-the-air, or OTA, update fails, it could literally render a car undrivable. In both scenarios, you're dealing with a captive receiver, a super narrow window of opportunity, and a payload that absolutely must arrive exactly as intended, without any corruption and without any distraction.
Now, what's really interesting here is the contrast between the two. On one side, we have the totally invisible power of persuasion, the ad script. It's a psychological payload. It's designed to shift beliefs and prompt you to take action. On the other side, we have the machine, the OTA update. That's a digital payload of ones and zeros specifically designed to alter the physical functioning of a 2-ton piece of machinery. Yet, as you dive into the sources, the disciplines required to execute both of these are basically mirroring each other. They both require relentless editing, rigid structuring, and a really deep understanding of the environment where that delivery is actually taking place.
All right, let's talk about extreme constraints. Look at these numbers, 65 to 80. According to the copywriting experts at Cybertise Media, that right there is your strict word count limit for a comfortable, natural-sounding 30-second ad script. That is barely 2 sentences per second. You have roughly 70 words to hook a total stranger, present a compelling message, prove your point, and drive them to take action. If you write 85 words, well, the voiceover artist has to rush, the viewer gets totally overwhelmed, and the message just crashes. Literally every single syllable has to earn its keep. But hold on. Let's flip the script. While an ad compresses an idea into a tiny space, automotive updates are dealing with massive physical scale. Modern vehicles don't just have one computer anymore. According to the National Highway Traffic Safety Administration, the NHTSA, they contain tens, sometimes even hundreds of heterogeneous electronic control units, or ECUs. We're talking about tiny computers controlling everything from your engine and your brakes to your windows and that fancy infotainment system, all talking to each other over internal networks. Updating the system remotely? It's like trying to successfully deliver a distinct, perfectly tailored message to 100 different people at the exact same time.
So how do you pull something like that off? You need rigid structure. The folks at Cybertise map this out perfectly. Your first 5 seconds must be a flawless hook. You have to stop the scroll, or stop someone from walking out of the room to grab a snack. The middle chunk, seconds 5 to 22, well, that delivers the core message. That's where you clearly state the problem, the solution, and the proof. And those final seconds, they are reserved strictly for the call to action, telling the viewer exactly what to do next. Every single second is deliberately engineered. If you blur these lines, or if you bury your hook at the 10-second mark instead of the start, the entire delivery fails.
And guess what? Over in the automotive world, the NHTSA demands a remarkably similar, strict 4-step methodology to safely update those hundreds of ECUs. First, you package the software for distribution. Then you transport it, the vehicle receives and authenticates it, and finally it installs. It's just like an ad script. If you skip or mishandle any one of these 4 steps, the whole delivery just completely falls apart.
Which brings us to what is arguably the most terrifying moment for our automotive payload, the transport phase. This digital package has to leave the cozy safety of the server, cross the highly vulnerable airwaves, usually via cellular networks or Wi-Fi, and actually arrive at the vehicle. This is where the payload is completely exposed. If the connection drops, or if a malicious actor intercepts and tampers with the data mid-air, the consequences are severe. It is the technical equivalent of your perfectly crafted commercial being broadcast with heavy static. The message just gets lost in the noise, or worse, it gets corrupted entirely. Speaking of noise, there's this really fascinating concept in ad copywriting highlighted by Cybertise. It's the idea that silence is a word. In a 30-second script, filling every single second with rapid-fire dialogue is actually a catastrophic mistake. Sometimes the deliberate absence of words, just a perfectly calculated pause, is exactly what allows the viewer to actually process the emotion or the information you just gave them. Deliberate pacing protects the message from becoming overwhelming noise. It's basically a form of buffering. You're giving the receiver the necessary space to unpack what you just delivered before you hit them with the next piece of data.
Now, just like bad code can crash a computer, ad scripts can completely crater due to specific structural flaws. CyberTies outlines some critical mistakes here, things like using generic, unbelievable proof, or burying a weak hook, tacking on a sloppy call to action at the last second, or, and this is a big one, writing a script just to make the client proud instead of actually speaking to the viewer's problem. And listen, these aren't just subjective artistic disagreements, they are structural failures. They literally prevent the payload from installing in the viewer's mind. When you commit these errors, the viewer's internal security system just steps in and rejects the message as totally irrelevant or untrustworthy.
Okay, but we have to shift to a much more serious tone for a second when we look at the consequences of a failed automotive update. Because look, a failed ad script, it just burns through a marketing budget. But a failed vehicle update, as the NHTSA report explicitly warns, the installation of malware is one of the biggest risks. If an OTA update isn't secure, or if a hacker manages to spoof a legitimate server and push forged software right into the vehicle's network, they could completely brick the vehicle's hardware. They could render it totally useless or even take malicious control of safety-critical systems while you're driving. That is terrifying.
Because the stakes are literally life and death, the NHTSA mandates non-negotiable defenses to protect that automotive payload. We're talking about things like code signing, which basically acts as an unforgeable cryptographic stamp of approval, secure bootloaders, and heavy encryption. Think of these as the ultimate cybersecurity bouncers at the door. It's the technical equivalent of keeping a marketing message laser-focused and totally uncorrupted. These mechanisms ensure the vehicle only listens to the authorized sender and immediately rejects any tampered instructions.
To bring this highly technical process back down to reality, take a look at this Genesis interface. This is the exact moment the vehicle prompts the user to authorize the payload. It is the ultimate call to action. The car has securely received the package in the background, it's verified the authenticity, and now it's politely asking the driver to press start. It's this brilliant moment where the digital realm pauses and hands control over to the human user to authorize the final critical step.
But the car doesn't just blindly accept that authorization and say, okay, let's go. No way. It demands incredibly strict physical conditions first. According to the Genesis manual, the vehicle must be completely off, the gear has to be in park, the parking brake must be engaged, and incredibly, even the hood has to be closed. The machine is essentially creating a lockdown, highly secure physical sandbox for itself. It's making absolutely sure that nothing interrupts the delicate process of overwriting its own brain.
And what happens if you try to bend the rules? The system is ruthlessly protective. If even one single element is off, like, oh, I don't know, you left your exterior headlights on, the system actively blocks the entire update. Why? Because leaving those lights on could drain the 12-volt battery during the update. That would cause a catastrophic power failure while it's writing to the flash memory, which could permanently brick the ECU. The system is meticulously designed to fail safely. It will always prioritize the integrity of the vehicle over the convenience of getting the update done quickly. But when all those strict conditions are finally met, the defenses are passed, and the user authorizes the action, boom, we achieve flawless delivery. The screen goes dark, a simple progress bar appears, and we get the safe, quiet installation of millions of lines of code running perfectly in the background. It is just a massive, beautiful orchestration of cryptography, network security, and user experience design, all resolving into a seamless, invisible upgrade to the machine you literally trust with your life.
So look, whether you are trying to carefully implant an idea in a customer's mind using exactly 75 perfectly chosen words, or you're distributing an encrypted firmware package to 1 million vehicles across the country, the core principles are exactly the same. It requires immense discipline, a deep understanding of your vulnerabilities, and a total commitment to flawless execution. I want to leave you with this provocative thought today. Is your next update, whether that's a pitch to a new client, a presentation to your internal team, or a literal download to your dashboard, truly secure and effective? Have you actually built the right architecture to ensure your payload arrives exactly as you intended? Think about it. Thanks so much for joining me on this explainer, and I'll see you all next time.